Welcome to Staffworks Explained. If you are here for the first time, please consider subscribing to this channel. In today's video, we'll be talking about Tanzania SGR, specifically the Tabora Kigoma lot. The lot between Tabora and Kigoma, where we talk about inside Tanzania's most strategic railway project as construction gains momentum. By any measure, the Standard Gauge Railway's SGR has become the defining infrastructure program of modern Tanzania, stretching from the Indian Ocean at Dar es Salaam towards the western frontier. It is steadily reshaping the country's transport landscape, shortening travel times, lowering freight costs, and reinforcing Tanzania's ambition to become the principal logistics gateway for East and Central Africa. In July 20th, 2026, attention shifts to Kigoma, where President Samia Suluhu Hassan is expected to officiate the launch of Tabora Kigoma Standard Gauge Railway Lot 6 during a one-day visit to the region. While described as a launch, the event comes after construction activity had already begun, with contractors mobilized on site, engineering works underway across several sections of the corridor. According to the regional authorities, physical works have already progressed beyond 10% mark, making the ceremony less a groundbreaking in the literal sense and a national information of a project already taking shape on the ground. Symbolism is significant. Unlike early SGR phases that linked the commercial capital to country's political and economic heartland, of the Tabora Kigoma section extends the railway to Tanzania western frontier, where it will connect with Lake Tanganyika and lay the foundation for the future links into Burundi and Eastern Democratic Republic of Congo, DRC. Here, we examine what has been built so far, the current state of implementation, the engineering works already visible, the financing structure, the project technical complexity, the challenges affecting delivery, and why many transport economists consider this to be the most strategically important phase of the Tanzania SGR program. In this analysis, we draw on project documentation from Tanzania Railway Corporation (TRC), financing documentation from African Development Bank, and government announcements, as well as contractor information. For more than 100 years, now let's talk about the missing link in the Tanzania National Railway Vision. For more than 100 years, the railway between Tabora and Kigoma has served as Western Tanzania's principal transport artery. Constructed during the German colonial administration and later expanded under British rule, the meter gauge railway Central Line connected the port of Dar es Salaam with Lake Tanganyika. It played a vital role in transporting agricultural produce, minerals, fuel, passengers across the country. However, decades of underinvestment left the line struggling to compete with road transport. Reduced speed, lighter axle load limits, as well as aging infrastructure increased transport costs while limiting the railway ability to support Tanzania's growing economy. The Standard Gauge Railway represents a complete departure from that legacy. Rather than rehabilitating the old line, Tanzania has chosen to build an entirely new electrified railway designed for demands of modern freight and passenger transport. The Tabora Kigoma section is the final domestic segment of the central corridor before the railway reaches Lake Tanganyika. Once completed, freight originating at the port of Dar es Salaam will move entirely on modern electrified infrastructure to western Tanzania before continuing to lake transport or future international railway connections. Now let's look at the railway measured in strategy, where we say it's not just kilometers. On paper, the figures are straightforward. The project covers approximately 506 kilometers of new electrified SGR at a contract valued at Tanzania shillings 6.3 trillion, equivalent of roughly 2.2 billion US dollars at the time of the signing. The contract was awarded to China Civil Engineering Construction Corporation (CCECC) under the supervision of Tanzania Railway Corporation (TRC). Yet the railway importance cannot be understood through cost or distance alone. Transport planners increasingly describe the Tabora Kigoma line as the western gateway of the Central Corridor. It connects directly to future projects proceeding from Uvinza towards Burundi, with longer-term ambitions in serving Eastern DRC. That regional function has attracted support from institutions such as African Development Bank, which sees the corridor as an essential component of Eastern Central Africa trade integration. Let's now look at the route which traverses Tanzania Western Heartland. From Tabora, the railway heads west through predominantly agricultural landscape before reaching Kaliua, one of the western Tanzania important transport center. It continues through Uvinza, a location whose importance has grown considerably in recent years. Although relatively modest in size today, Uvinza has effectively become the future railway crossroads of western Tanzania. Here, the planned international branch towards Burundi will diverge from the main Tabora Kigoma alignment, transforming the town into an operational junction linking Tanzania with neighboring countries. Beyond Uvinza, the railway continues towards Kigoma, terminating near the shores of Lake Tanganyika, where freight can transfer to the lake vessels serving ports in Burundi, Zambia, and Eastern DRC. For project planners, this multimodal integration is central to the railway economic case. Let's now look at the progress as far as construction is concerned, where you say it's slow on paper but substantial on the ground. One of the most persistent criticism directed towards Tabora Kigoma SGR concerns its pace of construction. According to the latest field performance evaluations verified by Tanzania Railway Corporation TRC, as well as regional authorities, the Tabora Kigoma phase has successfully surpassed the 10% completion threshold. The engineering, procurement, and construction management EPCM teams have successfully completed initial site clearing, earthworks, pioneering cuts along the right-of-way, structural substructure works on the primary bridge, as well as the drainage systems, and all these are well advanced. Viewed in isolation, those details may appear underwhelming for a project launched several years ago, but project managers caution against judging railway construction solely by percentage completion during the early phases. Railway differ fundamentally from buildings. Much of the work that determines long-term performance happens before the rail are ever laid. Engineers must first conduct geotechnical investigation to determine soil stability, relocate utilities, compensate affected communities, establish contractor camps, construct access roads, identify borrow pits, stabilize embankment, install drainage systems, and complete bridge foundations. These activities absorb considerable time and resources, but contribute relatively little to headline completion percentages. Only after the enabling works are complete does visible progress accelerate through simultaneous construction of bridges, embankment stations, permanent ways, as well as electrification. In that respect, the Tabora Kigoma project appears to be approaching a transition from mobilization to full-scale production. Let's look at one of the most important components, the Malagarasi Bridge, which we say is engineering the project most critical crossing. Among all the structures rising along the 506 kilometers corridor, none better illustrates the engineering ambition of the project than the Malagarasi Bridge. Spanning approximately 465 meters across the Malagarasi River through 17 reinforced concrete spans, it is one of the largest railway bridges currently being constructed in Tanzania, and unquestionably the defining engineering landmark of the Tabora Kigoma section. Project updates reported in the recent months indicate that the bridge has progressed to well above 80% completion, making it one of the most advanced major structures on the corridor. Its significance extends far beyond its dimensions. Malagarasi River is Tanzania's second largest river, among its most environmentally sensitive water courses. It drains an extensive catchment into Lake Tanganyika and experiences substantial seasonal fluctuations in water levels. During heavy rains, the river expands dramatically, producing powerful hydraulic force capable of undermining poorly designed structures. That reality shaped every stage of the bridge's design. Engineers first had to undertake detailed hydrological modeling to determine expected flood levels, rivers velocity, as well as long-term erosion patterns. Massive reinforced concrete foundations were then anchored deep beneath the river bed to resist scour. That's the gradual removal of soil around bridge piers caused by the flowing water. Scour has been responsible for failure of bridges worldwide, making it one of the most critical considerations in the river crossing design. Above the foundation, the bridge has been engineered to carry heavy capacity electric freight trains operating at substantial high axle loads than the century-old MGR trains. Unlike conventional road bridges, railway bridges are required to maintain exceptionally tight geometric tolerance. Even minor structures or depressions and repeated heavy loads can affect track alignment, increase maintenance, as well as associated costs, and that can compromise the comfort of those who are using the bridge. The bridge therefore functions as more than a river crossing. It represents one of the project's critical path activities, the sequence of construction tasks that directly determine the overall completion date. Delays on the structure of this scale cannot easily be recovered elsewhere because the western section of the railway depends upon it. Once commissioned, the bridge will eliminate one of the principal physical barriers along the central corridor, allowing uninterrupted rail movement from Dar es Salaam to Lake Tanganyika. Let's look at the stations, which are designed for the next 50 years. Unlike many traditional railway stations that functioned primarily as passenger stops, the Tabora Kigoma SGR stations are designed as integrated transport facilities. The engineering design introduces 11 specialized stations, spaced strategically to optimize regional cargo and passenger flow. The layout features one primary terminal at Kigoma, 3 medium-sized stations at Tabora, Kaliua, as well as Uvinza, 3 major regional intersections. We have 6 minor intermediate stations to handle localized passenger traffic and 1 dedicated marshalling yard. The marshalling yard serves as the sorting station where freight trains are efficiently reconfigured based on weight, cargo types, as well as final destination. Each of these stations is expected to incorporate signaling facilities, communication equipment, freight handling areas, electrical systems, as well as passenger amenities designed to accommodate future traffic growth. From a project management perspective, stations also serve operational purposes beyond passenger convenience. They regulate train movements, provide crossing opportunities on the single track sections, as well as accommodate maintenance activities without disrupting operation activities in the network. Let's now look at the hidden infrastructure, where we see the work that few people see. The visible rails often receive public attention, yet they account for only part of the railway project. Beneath the future tracks lies an enormous amount of civil engineering. Hundreds of culverts carry these seasonal streams beneath the railway embankments. Drainage channels protect the formation from erosion. Rock cuttings reshape hillsides. Engineered embankment elevate the railway above flood-prone terrain. Retaining structures stabilize steep slopes. Every one of these components contribute to long-term operational reliability. Neglecting them would reduce maintenance intervals and as well as increase life cycle cost for decades. And now the most important part of this is the financing framework, where we look at the capital expenditure as well as the debt structure. Executing mega projects of this scale demands highly disciplined and legally ring-fenced financial model. In this project, we have the capital expenditure, or the capex. The standalone contract value for the Tabora Kigoma Lot 6 expansion is valued at US dollars 2.2 billion, which is equivalent to 6.3 trillion Tanzania shillings. This specific investment brings Tanzania's total portfolio commitment to its wider SGR network to staggering 10 $1.04 billion US. The funding is architecture, where we have the Ministry of Finance having structured the capital through blended financing mechanism. Because local tax revenues are insufficient for massive asset creation of this scale, the state utilizes strategic external capital. The funding relies heavily on the concession loans as well as export credit facility. Global financial institutions with Standard Chartered Bank acting as the prominent lead arranger as well as coordinator across multiple segments. They have stepped in to secure long-term low interest credit lines. This approach minimizes immediate liquidity strains on the national treasury while spreading the debt amortization over the asset's productive life cycle. This financing model reflects a broader shift in Africa's infrastructure development, where governments increasingly combine sovereign investment with development finance rather than relying exclusively on state borrowing. Let's now look at the challenge which continue to shape the project. Like virtually every railway mega project, the Tabora Kigoma SGR has encountered obstacles. Land acquisition remains among the most significant. Hundreds of kilometers of new railway inevitably pass through farms, settlements, as well as community land, requiring compensation and relocation processes governed by national legislation as well as internationally recognized safeguard standards. Environmental management presents another challenge. The corridor traverses ecologically sensitive areas, particularly around major river systems, requiring continuous monitoring during construction. Then we have logistics, which also remain demanding. Western Tanzania lies hundreds of kilometers from major industrial supply centers, increasing cost and complexity of transporting steel, cement, heavy machinery, and railway materials. Global information has further complicated procurement. Since the contract was signed, international prices of steel, fuel, construction materials have experienced considerable volatility, forcing contractors to carefully sequence procurement to minimize cost escalation. Yet, perhaps the greatest problems or obstacle is maintaining the schedule discipline across hundreds of interdependent engineering activities. Railway projects operate much like a chain. Earthworks must precede ballast placement. Ballast must precede sleepers. Sleepers precede rails. And rails precede electrification. Electrification precedes signaling. Testing comes last. Any delay along this critical sequence has potential to affect the overall completion program. Let's look at the regional economies. Beyond Tanzania, why regional economies are watching this project. For Tanzania, the railway promises faster freight movements and as well as improved passenger mobility. For neighboring countries, its significance is even greater. Burundi and Eastern DRC depend heavily on external transport corridors to reach international markets. By extending electrified air transport to Tanganyika and as well as eventually beyond Uvinza towards Burundi, the Central Corridor offers these countries or economies as an alternative gateway to Indian Ocean. That strategic role explains why regional integration institutions as well as international financiers continue to support the project despite its scale and complexity. Now let's have a critical assessment. Measured purely against time lapsed since contract signing, it is reasonable to conclude that physical construction has progressed more slowly than many observers initially anticipated, even allowing for complexities of railway engineering, moving from mobilization to just over 10%. Physical progress reflects the reality that mega projects are often constrained by financing cycles, land acquisition, procurement timelines, as well as technically demanding structures such as Malagarasi Bridge. However, judging the project solely through headline percentages risks overlooking where the most technical demanding work has occurred. Completion of extensive earthworks, foundation construction, drainage systems, as well as rapid development or advancement of the Malagarasi Bridge suggests that the project is gradually transitioning into the phase where feasible progress typically accelerates. Coming months will therefore demonstrate whether the project is truly ready to meet the scale and complexity of the be particularly significant. If financing remains uninterrupted, contractor mobilization is sustained, as well as critical structures are completed on schedule, the railway should begin to show the type of visible transformation the public often associates with major infrastructure projects, that is the continuous embankments, completed stations, railway installation, as well as electrification progressing simultaneously across multiple fronts. In many reports or respects, the Tabora Kigoma SGR should not be judged merely by how quickly concrete is poured or steel is erected. Its ultimate measure of success will depend will be whether it permanently shifts trade patterns across East and Central Africa, strengthens Tanzania's position as the regional logistics gateway, and delivers an efficient, high-capacity transport corridor capable of serving the country's economics for generations. So thank you for reaching this far. If you are here for the first time, please consider subscribing to this channel. You can also watch other videos that we have made showing the progress of these lots or 6, as well as other lots in the Tanzania SGR. So thank you, and let's meet in the next one.